Multiplication was created to make repeated addition easier. In the same way, exponents were created to make repeated multiplication easier. Instead of writing 2 times 2 5 times, we simply write 2 to the power of 5. But what if we already know the results of that repeated multiplication and we want to find the original number? That is exactly the problem the square roots solve. Today we're going to learn about exponents and square roots, what they mean, the rules we use when working with them, and how they relate to each other. We begin with the exponent. An exponent is a small number written to the upper right of a base. If you see 3 squared, the 3 is the base and the 2 is the exponent. This means we multiply 3 by itself 2 times, which gives us 3 times 3 equals 9. If it were cubed, you would multiply 3 by itself 3 times, giving us 3 times 3 times 3 equals 27. The exponent tells us exactly how many times to multiply the base by itself. Now that we understand what an exponent is, let us look at the 8 laws that govern how we work with them. The first law is the product of power rule, written as a to the power of m times a to the power of n equals a to the power of m plus n. This rule says that when we multiply 2 terms that have the same base, you simply add their exponents together. For example, if we have 2 squared times 2 cubed, instead of calculating each one separately, you just add the exponents to get 2 to the power of 5, which equals 32. The second law is the quotient of powers rule, written as a to the power of m divided by a to the power of n equals a to the power of m minus n. This rule says that when you divide 2 terms that have the same base, you subtract the exponents. For example, 2 to the power of 5 divided by 2 squared gives us 2 cubed, which equals 8. The third law is the power of a power rule, written as a to the power of m all raised to the power of n equals a to the power of m times n. This rule says that when you raise a power to another power, you multiply the exponents together. For example, 2 squared all raised to the power of 3 gives us 2 to the power of 6, which equals 64. The fourth law is the power of a product rule, written as a times b all raised to the power of m, which equals a to the power of m times b to the power of m. This rule says that when you raise a product to a power, you distribute that power to each number in the product. For example, 2 times 3 all raised to the power of 2 gives us 2 squared times 3 squared, which is 4 times 9, giving us 36. The fifth law is the power of a quotient rule, written as a over b all raised to the power of m, which equals a to the power of m over b to the power of m. This rule says that when you raise a fraction to a power, you distribute that power to both the top and the bottom of the fraction. For example, 2 over 3 all raised to the power of 2 gives us 2 squared over 3 squared, which is equal to 4 over 9. The sixth law is the zero exponent rule, written as a to the power of 0 equals 1. This rule says that any non-zero number raised to the power of 0 is always 1. For example, 5 to the power of 0 is 1. This happened because when you divide a number by itself, the exponent subtracts 0 and any number divided by itself is always 1. The seventh law is the negative exponent rule, written as a to the power of negative m equals 1 over a to the power of m. This rule says that a negative exponent does not mean the number is negative. It means we flip the number into a fraction. For example, 2 to the power of negative 2 is the same as 1 over 2 squared, which gives us 1 over 4. The eighth law is the fractional exponent rule, written as a to the power of m over n equals the nth root of a to the power of m. This rule connects exponents to roots. For example, 4 to the power of 1/2 is the same as the square root of 4, which equals to 2. Exponents give us a way to express repeated multiplication efficiently, but there is an operation that does the opposite. Instead of multiplying a number by itself, it asks what number was multiplied by itself to produce a given value. That operation is the square root. A square root of a number is a value that when multiplied by itself gives you the original number. It is written using the radical symbol, and whatever is placed inside that symbol is called the radicand. For example, the square root of 16 is 4, because 4 times 4 equals 16. But roots are not limited to just square roots. We can also have a cube root, which asks what number multiplied by itself 3 times gives you the original number. For example, The cube root of 27 is 3 because 3 times 3 times 3 equals 27. The small number written outside the radical symbol that tells us what root we are taking is called the index. A square root has an index of 2 and a cube root has an index of 3. Exponents and square roots are two of the most important tools in mathematics. Exponents give us a way to express repeated multiplication efficiently, and square roots give us a way to work backwards from a result to find the original value. Together with the 8 laws we covered today, you now have everything you need to work with powers and roots in any expression. Thank you for watching.